Hi there, and welcome to this class. For this class, we look at the concept of solubility in chemistry. So look at the concept of solubility. So what's solubility by definition? Solubility is the maximum amount of a solute that can dissolve in a given amount of solvent at a particular temperature. Solubility shows how well a substance dissolves in another substance. So the key idea here to note when it comes to solubility, it's simply that solubility shows how well a substance can dissolve into another substance. That's all. So the ability of sugar to dissolve into water, what has gone through? It has gone through what? The solubility, right? That's the idea. So I'm saying that solubility shows how well a substance dissolves into another substance. That's all. Now, when it comes to solubility, from the definition I gave you, you begin the idea of, you begin the word solute, solvent, temperature, right? What are all these? What they mean? What are these things mean? What they mean? What's the meaning of solute, solvent, right? Temperature, regarding solubility. Let's look at the concept of the basic terms involved in the study of solubility. All right, look at the basic terms. In the study of solubility, number one is called the solute. Number one is called the solute. So when it comes to solubility, right, perhaps the rate at which we check the dissolve of a substance with another substance is solubility. But where's the idea? What is solute? Because there are two substances that are combining to form a solution, right? So what is solute? So here's the task. A solute can either be a liquid, gas, or solid. So here's the idea. I'm saying that a solute is simply a solid or liquid or gas, given that it's combined with a liquid. So I'm saying that a solute can either be a solid, liquid, or gas, provided that that stuff is combined with liquid. That's all. So if I'm having sugar is perhaps a solute. If I have table salt, it's a solute. Why? Because this sugar and salt, I want to combine them with water. So provided that I combine sugar and salt with water, that sugar and salt is called a solute. So I'm saying that a solute can either be liquid, gas, or water, provided that what these are combined with a liquid, right? So it can't I'm coming before then. A substance, note please, a substance that dissolves in a solute, can be solid, liquid, or gas. So this is a substance that dissolves in a solvent. Please note, please, solvent, please, not solute. A substance that dissolves in a solvent can be solid, liquid, or gas. So here's the idea. The first term is called solute, and I'm saying that solutes can either be liquid, gas, or water. The task is that stuff must be combined with a liquid. Either it's dissolved or it's not dissolved. Solute is a solid, liquid, or gas. That's all. So far that stuff is combined with water. That's the idea of solute. Number two, let's look at the concept of solvent. Alright, solvent. So what is solvent? Now I said when it comes to solute, we said we're using sugar, right? So that sugar must be combined with what? A particular liquid. Now that liquid is called what? The solvent, right? That liquid is called what? Solvent. So solvent is more of like the liquid to which that solute is being combined to give a solution. That's like that. So I'm saying that a solvent is water technically, right? Yeah, water, kerosene, right? Petrol, if you want to. So the solid there is a liquid, water. While solvent is the water, while the solid is the sugar. If I mix the two of them, that gives me what a sugar solution. So in that case, yeah, solute is your solid liquid or gas. Solvent is the water to which that solute is being mixed with, right? To give a solution. So definition: a solvent is a substance that dissolves the solute. A solvent is a substance that dissolves the solute, usually a liquid, most commonly water. It is presented in larger amounts. It is presented in larger amounts than the solute. Alright, so when it comes to the idea of mixing water with sugar, it is technically okay when the sugar is small and the water is is more, because solids are always presented in larger value than the solvent. So my sugar can be much than the water, right? So it means that in my solute I can have a cup of water, and I just use perhaps probably 2 spoons of sugar into the water, and I sprinkle it and it dissolves. In that case, it gives you a sugar solution, right? So that's the second terminology in the study of solubility, right? So the third one there is called solution. All right. So the third term there is called solution. So what's a solution? A solution is a mixture formed when a two solutes dissolve in a solvent. That's all. If my sugar dissolves in my water without seeing anything, it dissolves, it disappears, it means that thing will form a solution. For instance, if I have a chalk grounded, and chalk is a solute, water is my solvent. If I combine my grounded chalk with water, what will happen? It will not dissolve. You see the particle up, right? In that case, it is not called chalk solution. It's called a suspension. So suspension is formed when your solute and your solvent combine, and it could not dissolve. Because if I if you ground a chalk and put it in water, it won't dissolve. You see the particle up and everywhere. So that one creates a suspension. For instance, if I have also sand and water, right? The sand particle is still there, you see it there, and the water you see it there. That's the suspension, right? So so I'm saying that solution is always formed when your solute and your solvent combine and it dissolves. Like instant, we said sugar and water. When sugar combine with water, it will dissolve, no problem. That gives you a sugar solution. If I have salt combined with water, this man can dissolve. If it dissolves, gives you a salt solution. But if I have chalk and water, it can give you chalk solution. It gives you a suspension. Why? Because that chalk cannot dissolve in water or perhaps in the solvent. That's basically the idea of solution. Solution is got by combining a dissolvable solid with liquid. That gives you a solution. One last terminology is called temperature. One last one is called temperature. All right. So when it comes to temperature, we know it is simply the degree of hotness and perhaps coldness of substance, right? But in this case here, we are focusing it in another dimension, in the idea of solubility. So note please, temperature please, note. This affects solubility. This affects solubility. This affects solubility. So when it comes to temperature, it's a critical part that affects solubility. Now imagine Imagine I have a boiled water and I have a cold water. In the boiled water, either it's boiled or not boiled, it's still what is solvent, is a liquid. Now, when the water is heated and when the water is cold, if I apply sugar in the heated one, the rate at which that sugar will dissolve will be faster than the rate at which that sugar will dissolve in cold water. So temperature plays a crucial role when it comes to the idea of solubility. So I'm saying that it affects solubility, not just ordinary effect. It creates a great change in the solubility of a substance, right? So at this junction here, I would like to explain these two stuff. So under temperature, know this please, note. Under temperature, please know this please. So for solid in liquid, if I have a solid in a liquid, such that probably my temperature, so if I have a solid in a liquid, such that I increase the temperature, if temperature is increased, it means that what? The solubility will also want to increase. So solubility. So if I have a salt and a water combined such that I increase temperature, if I increase temperature, it means that what? The solubility, which means the rate of its dissolving will what? Will also increase. That's first thing to note when it comes to solid in liquid. So when you increase temperature, automatically the solubility, the rate of dissolving will also increase. Also note, for gases in liquid, if I increase temperature, for gas, if a gas is in liquid, if I increase temperature, all our solubility, the solubility will decrease. So the solubility will decrease. So note that if I have a solid in a liquid such that temperature is increased, it means that solubility increases. If I have a gas in a water such that temperature increases, note that what the solubility was there will decrease. This is a very important concept to note when it comes to temperature regarding the concept of solubility. At this junction, let's look at another important concept called types of solubility. Perhaps type of solution, types of solution. Alright, so we said when it comes to solution is got when two substances, which in this case solute and solvent, can combine, and when they combine, they can be dissolved. So if they can be dissolved, it forms what then a solution. So I'm saying this now. Let's look at the types of solution. Basically, there are three types of solution. We have the saturated solution, unsaturated solution, and what the supersaturated solution. Let's look at these types one after the other. Alright. Number one, types of solution. Number one, we have the unsaturated solution. Number two, we have the saturated solution. And finally, we have the supersaturated solution. So these are the three types of solution that we have. We'll look at them one after the other as we proceed in study of solubility. Alright, so let's explain the first one called the unsaturated solution. So when two things combine to give a solution, there are still types of solution. So which one will give you unsaturated solution, which one will give you saturated solution, and which one will give you a supersaturated solution? I won't waste much time here. Give the definition and explain and move on, please. So let's explain number one. Let's look at the first one called unsaturated solution. Definition, please. An unsaturated solution is a solution that can still dissolve more solutes in a given temperature. If you add more solute and it still dissolves, the solution is saturated. Alright, that's basically how you illustrate or perhaps explain the idea of unsaturated solution. We said this: if I combine salts, observe this, if I combine salt with perhaps water, perhaps H2, so this salt here is my solute, this one here is my solvent. If I combine this together, technically this stuff will form what? A solution, right? A solution. Now the question is this: which type of solution this one form? It will form what there? It form what? Unsaturated solution. Why? Because we know that salt and water can be dissolved. So the idea is this: if something can dissolve in water, call it what? Unsaturated water solution. If it cannot, call it what? Saturated solution. That's the idea. So for this one here, salt combined with water to give you salt solution. So this solution here, I'm asking now, this solution here, is it saturated, unsaturated, or supersaturated? It is what? Unsaturated. Why? Because it is dissolvable. And the more you add salt inside this water, the more you can see the salt, or the more the salt dissolves, it's still what there? It's still unsaturated solution. That's the idea behind unsaturated solution, please. Number two, called saturated. Number two, saturated solution. Forward. Definition for saturated solution. This is a solution that can't dissolve any more solute at a given temperature. This is a solution that can't dissolve any more solute at a given temperature. Now, let's say for instance, my salt level. Let's say for instance, there is a rate whereby if I have water and salt this way, water and salt can be dissolvable. But the more the salt, there will be a level where the more you add the salt, it won't dissolve again. So imagine I have a level of water such as this, because unsaturated solution can be derived from saturated solution. This one here can be got from what? This man here. The excess of this man gives you what? The saturated solution. So imagine I have salt of 50 kg and I have just water, just 1 liter of water. If I pour it inside, you will see the salt clearly. It won't dissolve finish. In that case, that becomes what there is saturated what? Solution. So the excess of your solute in your solvent, and in a case whereby it can be dissolvable again, because what automatically what? A saturated solution. Not that it can't dissolve finish or is displaying above. You will see that salt in that water clearly. So in that case, it's no more what there unsaturated. It's because what there is saturated solution. Alright. So I'm saying this: if I have a level of water, perhaps solvent first, a level of sugar, the level of sugar is here, combined with the solvent, the level of water is here, H2O. Observe that the water is small here, the sugar is more than the water. If I pour the sugar inside this thing, you see sugar particle here. In that case here, this one gives you what? It gives you what? A solution, right? But what kind of solution? Saturated what? Solution. So this one gives you a saturated and solution. This is the basic expression for saturated solution. Let's do the idea of supersaturated solution. Let's look at supersaturated solution. Number 3. Alright. Supersaturated solution. Definition: a supersaturated solution contains more solute than it normally should at that temperature. It is unstable and easily crystallized. Note: a supersaturated solution contains more dissolved solute than a saturated solution at the same temperature. That's basically the idea of supersaturated solution. So for supersaturated solution, this one here will take me to the idea of when you have a chalk and water. So when a chalk and water combines, we just said that it will give you a solution, rather this what there is suspension. So a case of sugar and water, sand and water, or mold like your clay, whatever there, with water, these three here can't give you a solution, rather this what there is suspension. So I say note this, please note: anything that does not dissolve in water forms a suspension or a mixture, but is not a solution. I said anything that does not dissolve in water forms a suspension or a mixture, but it is not a solution. Example: chalk and water, sand and water, and then etc. Let's look at one last important concept before we leave for solubility. Solubility has calculation. We'll look at calculation of solubility in our next class. Let's just do the introduction and the theoretical part of solubility for this class. So next class, look at the calculations of solubility in solubility per se. One last thing called factor affecting solubility. Factor affecting solubility. Solubility. Number one there. Factor affecting solubility. Number one, I have temperature. As I've explained earlier, temperature is it has a great effect to solubility of a substance. Number two, pressure. Number three, nature of solute and solvent. Alright, these are the three factors that affect solubility. So note these three factors: temperature, pressure, and nature of solute and solvent. We just said that for temperature, if temperature increases, what type of solubility? It will increase. I just said that earlier. Okay, keep the body. If temperature increase, solubility increase. But if gas in a liquid, if I have a gas in a liquid such that temperature increases, solubility what there decreases. That's the idea for temperature. For pressure there, if I increase the pressure of a solubility, it means that the solute of the gas will increase. If I increase the pressure in a solubility, what will increase is there? The gas. So the gas of the solute what increases. So note, temperature, if I increase temperature, solubility increases. If I increase pressure, the gas of that solute what there increases. That's the technical understanding you need to know when it comes to temperature and pressure. Nature of solute and water, of course, yes, this affects, perhaps this is a factor that affects solubility. So these are the factors affecting solubility, temperature, pressure, and nature of solute and solvent. In the next class, we'll look at the concept of calculation of solubility in our next class. If you want to like this video, share to your friends and classmates like a link to. See you guys in the next class, and welcome to Excellent Link Academy.
Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAEC and JAMB classes membership. If you're preparing for WAEC or JAMB, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits. Before we continue, let me quickly share something that can change your entire online journey. I just launched a complete YouTube Mastery course, a step-by-step training designed to help beginners start and grow a successful YouTube channel using only their smartphone. In this course, I break everything down in simple, practical lessons. No expensive camera, no studio, no complicated equipment, just your phone and the right knowledge. You will learn how to create quality videos, design engaging thumbnails, write perfect titles, choose the right niche, understand the YouTube algorithm, and grow your channel from zero, even if you've never created a video before. If you want to become an online teacher like me, this course will guide you on how to teach online, record lessons, explain concepts clearly, and attract the right audience. And if you want to create content in any other field, lifestyle, motivation, entertainment, business, this course will still show you the exact steps to succeed. All the lessons are pre-recorded, well-organized, and easy to follow. You can watch them at your own pace, anytime, anywhere. So, if you've been dreaming of starting a YouTube channel but didn't know how to begin, this is your opportunity. This course will take you from beginner to confident creator. The link to get the YouTube Mastery course is right there in the video description. Click it and start your YouTube journey today. Before we continue with this lesson, I'm excited to announce that I just launched my official website, a complete learning platform designed to help you study smarter, learn faster, and access high-quality educational resources anytime you need them. On the website, you'll find several well-structured courses created to guide you step by step through the most important topics. First, we have Organic Chemistry for Beginners, a simple, beginner-friendly course that breaks down organic chemistry into easy explanations anyone can understand. Next, there are WAEC and JAMB classes, specially designed to help you pass your exams with confidence using clear lessons, solve questions, and exam strategies. We also have the Physics tutorial for Year 1 students, covering foundational concepts you must master in your first year of higher education. And for anyone who wants to grow online, there is a complete course on how to start, grow, and earn on YouTube using only your smartphone. This course gives you everything you need to begin your YouTube journey without expensive equipment. There is also a book section on the website where you can get all my educational books, including the shortcut to academic success. My website is now your one-stop platform for science tutorials, exam preparation, YouTube training, and learning resources that can transform your academic and digital journey. To explore all the courses and get your copy of the books, simply click the website link in the video description. Hold on, before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you.